Hi, this is Mr. Flint, and we're looking at a new skill today called variational problems. With these kind of problems, we don't end up using the formula in the same traditional way that we have used formulas before. A variational problem doesn't give you specific numbers like what we've used before to plug into an equation. Instead, it asks, what if one quantity is multiplied by some number, what would the other quantity be multiplied by? So let's go through some examples together. And you also have an example on the new skill variational problem skill sheet. So make sure to look at that too, glue that in the back of your notebook. All right, now, your first problem here says a car traveling with a speed of v takes 180 seconds to travel a certain distance. How long would it take another car traveling at a speed of v times 2, or 2v, to travel the same distance? That's twice the velocity. So we're going to use a version of the guess method in order to solve these problems. So let me get my pen going here and look at our givens and our unknowns. Now we're going to look at those together. It's actually easiest to find our unknown first, because here in the problem it says, how long would it take another car traveling at a speed of 2v to travel the same distance? So how long would be time? And we don't know time. Now, what are the other variables in this problem that are given to us? Well, it says that a car traveling with a speed of v, so we've got a speed here, takes 180 seconds to travel a certain distance. How long would it take another car traveling at the same speed to travel the same distance? So we've got distance here, same distance. Okay, so in this case, we are multiplying v times 2, and we get that right there. So let's put that right here. V times 2, and d is the same distance. That implies that it's being multiplied by 1, and we'll always have one thing that's being multiplied by the number 1, and another thing being multiplied by some other number, a number greater than 1 or less than 1. Now, we don't know time, and we've got to figure out how much it's going to be multiplied by. So let's find an equation. All right, we've got velocity, distance, time. What's an equation that goes with that? Well, speed equals distance over time. And we need to solve this for time, so let's rearrange this. Solve it for time. Time is equal to distance over velocity. All right, now, let's look at our multipliers here. Distance is multiplied by 1, what we can see over here. And velocity is multiplied by a factor of 2 right here. All right, so that's going to help us figure out what time is multiplied by. It's got to be multiplied by the same quantity ratio over here. So it's going to be multiplied by a factor of 1 over 2, just like on the other side. So we've got to multiply this. Sorry, I should have put the multiplication sign here to be consistent. Okay, multiply this by 1 over 2. So we're going to take our time and multiply it by 1/2. Well, the original time was 180 seconds. All right, now we need to make sure to multiply that by 1/2, just like what we figured out up here. We'll multiply that by 1/2, and we'll get a new time of 90 seconds. So if we have a car going twice its original velocity over the same distance, it should take half as much time. It should take only 90 seconds if it took 180 seconds before, which intuitively kind of makes sense. So let's look at another problem here, problem number 3. An airplane that travels with an average speed of 90 meters per second reaches its destination over the course of t seconds. Another airplane traveling the same route takes 4 t seconds to travel the same route. What is this plane's average speed? So again, we're going to do like the givens and the unknown, and I like finding that unknown first. It says, what is the average speed? So we don't know that. So we don't know average speed. We've got to find that out. So what other information do we have here? An airplane that travels with an average speed of 90 meters per second reaches its destination over the course of t seconds. So we've got t seconds. We've got time here. So there's one of our variables. Another airplane traveling the same route takes 4 t's. Okay, so same route, that implies a distance here. All right, so 4t implies that we're going to have this time multiplied by 4, and here we're going to have distance multiplied by 1. That's our constant there. Just like before, where I was going to have one thing multiplied by 1 and something else multiplied by a number greater than 1 or less than 1. So now let's find an equation. Well, it uses the same equation as number 1, where we've got velocity equals distance over time, but we don't need to do any rearranging because this equation already solves for velocity. So now let's set up our factors here. Time is being multiplied by 4, and distance is being multiplied by 1. Okay, so that's 1 over 4. So it's like taking and multiplying velocity by 1 over 4, or 1/4. So the original velocity was 90 meters per second, and now we need to multiply that by a factor of 1/4, which we found out right up here. So 90 times 1/4 gives us 22.5 meters per second for the new velocity. So if it takes 4 times as long to go the same distance, it's going to have to go 4 times as fast, which again intuitively kind of makes sense there. All right, number 5. A ball set on a smooth inclined plane will have a constant acceleration. If the ball is allowed to roll for t seconds, it rolls a distance of 5 meters. The experiment is repeated, but this time the ball is allowed to roll for 4t seconds. How far will the ball roll during the second experiment? So givens and unknowns, and I like finding that unknown first. How far? So we don't know how far, and that's going to be a displacement or a distance. So our unknown's a displacement or a distance, and we don't know that, what it is. Okay, then let's look back in here. A ball set on a smooth inclined plane will have a constant acceleration. So acceleration is constant, meaning it is the factor multiplied by 1. If the ball is allowed to roll for t seconds, okay, it rolls a distance of 5 meters. The experiment is repeated, but this time the ball is allowed to roll for 4t seconds. So we're multiplying time by 4. Now, we've got to find an equation that has acceleration, time, and distance or displacement, and hopefully you know this one. Displacement is equal 1/2 at squared. All right, and so it's already solving for displacement, so we don't need to rearrange it. Yay! Now let's figure out what these multiplying factors are. And let's look at this 1/2 too. So we always ignore coefficients, and that's on your skill sheet. It says under that first bullet where it says 2 important notes, coefficients like 1/2 get ignored. They're always ignored. The 1/2 was there before the quantities were multiplied, and the 1/2 is still there after the quantities are multiplied, so the 1/2 doesn't change anything, so we can just get rid of it. Don't need to worry about it at all. So now let's look at these other two things and see what they're multiplied by. Acceleration, again, is constant, so it's multiplied by 1, and time is multiplied by a factor of 4. Now we've got to be super careful here because it's actually, we don't ever ignore the exponents. That's your second bullet there. Exponents and radical variables are extremely important and must be put on your multipliers as well. So don't forget this. Don't forget to make sure to put that square there. All right, so, well, what's that going to be like multiplying our x by? Well, let's look here again, and let's take that 4 and actually square it. So it's like multiplying by 16 here. So 1 times 16, that's like multiplying your x by a factor of 16 somehow. So x is going to have to be multiplied by 16, okay, just so that we can get this a, which is being multiplied by a factor of 1, and then this t squared, which is being multiplied by a factor of really 16 here. So we've got to make sure to include that. So our distance is originally was 5 meters. So it was originally 5 meters. We've got to multiply that by a factor of 16, which gives us 80 meters as our answer. All right, so let's do a couple more. Number 7. Number 7 says 2 inclines A and B have different angles but the same length. The ball set on incline A has an acceleration of 3.2 meters per second squared and reaches the bottom of the incline in time t. The same ball, when set on incline B, travels the same distance in a time 4t. What is the ball's acceleration on incline B? So again, I like listing out those givens and the unknown, and I like finding the unknown first. Come back here. What is the ball's acceleration? So that's the unknown. We don't know what the acceleration is this time around. All right. Now, the other factors that were given in here, they have the same length. So the x, the displacement or the distance is constant. That's our multiply by 1 factor. our variable. We multiply that variable by 1, and then time is the next one. Okay, so it has an acceleration of 3.2 meters per second squared and reaches the bottom in a certain amount of time. So we've got same length of ramp, so we knew it was multiplied by 1, and then time is being multiplied by a factor of 4 here. Okay, so the same ball when set on the incline B travels the same distance in time and 4t, time 4t. So we've got to multiply t by 4. So we are come back to that same equation of x equals 1/2 a t squared. All right, this time we have got to solve for acceleration. So let's rearrange this to solve for acceleration. Multiply this side by 2 to get rid of the half. Multiply this side by 2. So 2x equals a t squared. All right, so then we've got to get rid of the t squared. It goes away here. T squared here. So next. All right, so we get acceleration is equal to 2x over t squared. Okay. All right, so now let's do our multiplying factors here. We are going to take the x and multiply it by a factor of 1, or the displacement is multiplied by a factor. And we get that from up here. Now, the t is multiplied by a factor of 4, but we've got to be careful because this time around it is squared, okay? So we've got to make sure to square that. Now, we always ignore the coefficient, so we can cross that out. So let's see what that really is like, acceleration being multiplied by. So we've got a equals, and we'll not worry about the 2, so we've got x times 1 over t squared. Okay, so that's like multiplying this by a factor of 4 squared. So really, it's like taking and multiplying a, okay, by 1, factor of 1, so multiplying this over t squared, which is 16, a factor of 16. So we've got to look at 1 over 16. So it's really like taking our acceleration and multiplying it by a factor of 1 over 16. All right, so here we've got that set up, multiplying acceleration by a factor of 16. The original acceleration was 3.2, and we've got to multiply that by a factor of, 1 over 16. Okay, so because this is 1 over 16, so we've got 1 over 16 here, not a factor of 16, 1 over 16. So we've got to multiply this by a factor of 1 over 16. And when we do that, we get it's going off the screen a little bit. Acceleration is equal to 0.2 meters per second squared. Don't forget to put your units on there. All right, so let's do one more problem. Here's number 9. A ball falls from the top of a very tall building, a distance d, and a time interval of t. How long must the time interval be in order for the ball to fall a total of 70? So how long must the time interval be? So when we do our givens and our unknown, it's easy to find our unknown, or of course our unknown is going to be time. We don't know that. So we have the top of a very tall building, so it's going to go some distance. That's going to be x, or a distance d, so displacement. So it's going to be some distance. And that actually is going to be multiplied by a factor of 7. So we know that already, multiplied by a factor of 7. Now, there's something in here that is not given to us, but it's implied. It's falling, so it's in free fall. So we know the acceleration here is going to be constant. So that's actually the thing being multiplied by 1 in this one. So that's what makes this 2-star problem a little bit more difficult, is that acceleration is implied and not expressly given to us in the problem. So we do the same equation of x equals 1/2 a t squared, which we have been using recently. We've got to rearrange that, and so I'll rearrange that for you. And we've got to solve for time. So t equals the square root of 2x over a. All right, so then we need to do our multiplication factors. X is being multiplied by a factor of 7. A is being multiplied by a factor of 1. Okay, and so we ignored this. So that is like taking and multiplying this side by a factor of 7 over 1, or taking and multiplying this by a factor of the square root of 7. Now, there was no numbers to plug in at the top, so this ends up being our answer. Now, the answers to the rest of them are right here, so you can come back and look at this. So that's it for now. go ahead and feel free to ask us questions.